Good afternoon, everyone. My name is Mark Carlino, and I'm the president of Connecticut chapter of ITE. And I'd like to welcome each of you to our Connecticut ITE, ITS Connecticut joint winter meeting. I think we've got a very exciting presentation for you just in a few minutes, but I'd like to start with a couple of announcements from Connecticut ITE. In a few weeks, you'll be seeing nomination or our candidates for our secretary position in Connecticut ITE. We have a full slate of candidates. We have Neil Olinsky and Jay Lockaby, who will be our candidates for the secretary position. I'd like to thank the nominating committee for their hard work in putting that forward to the directors. One thing I do want to point out is that those of you who are full ITE international members will be eligible to vote in this election. Remember that the Connecticut chapter is no longer collecting dues, and all the dues are being done through the international chapter. And you'll be soon receiving an email if you're an international member for this voting. I'd like to remind everyone to go to our website for job postings. We have a couple that are on there now, and I think that they may be of interest to some of us on the call today. And then coming in April will be our upcoming spring meeting for the Connecticut chapter. We'll be sending out a notification about that meeting and the events associated with it in a few short weeks as well. And with that, I'd like to turn it over to CJ Ganza, the ITS president, for a couple of announcements from them. Go ahead, CJ.
Good evening, everybody. Thank you for attending this meeting. It's great to keep this meeting going annually, even though it's in a virtual environment. Just a couple quick points from ITS. We decided to waive our 2020 dues due to the pandemic financial situation of a lot of our member organizations, and also the fact that we're not really doing too much. We don't have a lot of expenses, so we figured it was fair to not accept dues for the year. We will decide about 2021, see how things go, and so look for an update on that. We're very optimistic and hopeful we'll have an annual meeting like usual in September at the Hawthorne with a full vendor showcase, bigger and better than ever before. Other than that, it's everybody stays safe, right? Thanks.
Thank you, CJ. And with that, I'd like to get right to our main presentation. We're very pleased today to have Matt Bloom and Jay Lockaby with us, who will be presenting on an upcoming project that Connecticut DOT has been working on over the last few months and last years. It's a replacement of traffic signals along US Route 5, Route 15, which is the Berlin Turnpike, in the towns of Berlin, Newington, and Wethersfield. Matt Bloom is a PE and PTOE as a supervising engineer in the traffic operations unit of Connecticut DOT's Division of Traffic Engineering. He holds a bachelor's degree from the University of Hartford and a master's degree from UMass Amherst. Prior to joining the department in 2017, Matt spent approximately 10 years as a traffic engineer in Connecticut's consulting industry, working on a wide range of traffic projects, and another 10 years serving a local municipality in Connecticut. Jay Lockaby is a transportation engineer with the traffic signal unit within ConnDOT's Division of Traffic Engineering. He graduated with a Bachelor of Science in Civil Engineering from the University of Tennessee and has worked with the Division of Traffic Engineering ever since joining ConnDOT in 2014. He currently is the project engineer for ConnDOT's project to replace the computerized traffic signal system and deploy adaptive signal control and connected vehicle technology along the Berlin Turnpike. And with that, it's my pleasure to turn it over to Matt Bloom for this presentation. Take it away, Matt.
Thanks, Mark. Again, my name is Matt Bloom. Today we're talking about Connecticut DOT Project 7250, which is really a traffic signal technology pilot project. As an outline of the meeting, we're going to start with a quick overview, talk about the proposed improvements that are going to be implemented as part of this project, get into a little bit of the technologies that we're looking at, as well as some of the decision process that we had to go through to figure out what we wanted to implement along this corridor, and then take questions and answers. The project team included Mark Carlino and Mark Macu, who really led this project. Myself and Jay Lockaby, who worked on the project. Janet Kaiser from Gannett Fleming was the consultant that designed this project. And there are two people that aren't pictured but really deserve some recognition. That's Lisa Conroy, who really oversaw a lot of the design elements, and John Cordy, who oversaw a lot of the ITS components. So the project, like Mark had mentioned a second ago, it involves 15 signalized intersections along the Berlin Turnpike, starting at Knott Street and continuing south to Raleigh, Selden. This is the first of two phases. The second phase is the next 13 intersections to the south towards Meriden. As I'm sure everybody on this call is familiar, the Berlin Turnpike is a heavily used commercial corridor, ranging from 4 to 6 lanes. There's about 30 to 45,000 ADT along the corridor. And something that causes a significant impact to this corridor is that it's used as a bypass whenever there's an incident on I-91. And the availability of navigation systems with rerouting capability is really compounding the congestion that we see associated with incidents on 91. As far as existing conditions are concerned, the corridor has aging signals and technologies. Some approaches on this corridor still have 8-inch heads. The corridors run with NASDAQ TS2 controllers. It's a NASDAQ system with copper communications. Pedestrians are accommodated with side street green. And there are actually 2 separate systems along these 15 intersections. There is one with 8 patterns to the north, one with 6 patterns that's to the south, and there's 2 incident management patterns. One is for I-91 incidents, and the other one is for snowplow issues during the winter. Some of the limitations that we have, we really have limited flexibility in programming of signal timing. Timing really can't be easily adjusted to manage increases in traffic due to an incident, such as on I-91. I did mention earlier that there's a timing plan specifically for I-91 incidents, but it really doesn't account for diverted traffic volumes, duration, time of day, or several other variables. Timings don't adjust to accommodate the seasonal ebbs and flows that are found on this corridor. And we have very limited data feedback, which would help engineers improve efficiency. Something I wanted to mention while we're just talking about aging technology, and I really just threw this slide in to reinforce the fact that the department's moving away from in-pavement detection technologies, primarily because it relies on the pavement condition to function. It could be damaged by changes in weather, utility work, and maintaining loops is a challenge and costly, and it actually requires personnel to work out in the road, which we don't really prefer. So before we get into what specifically we're proposing, let's just talk quickly about what our objectives were. First and foremost, we're looking to maintain our traffic signal assets in a state of good repair. We also want to improve vehicle, transit, and pedestrian mobility. We want to increase efficiency and reduce emissions. We want to improve safety and reliability always. We want to implement technology to manage traffic flows. And we want to provide tools to help engineers to optimize the traffic flow along the corridor. So we came up with a scope of work. And that includes, I guess, starting with some physical features. The corridor is going to implement mast arms. Mast arms are the department's preferred structure type. It allows a much greater flexibility in mounting cameras and other technologies than you'd get with a span wire. Because it's such a wide corridor, very long mast arms are going to be implemented as part of this project, up to 80 feet in length. They've been designed in-house, and we've done that to expedite the materials acquisition process, and potentially as a new path forward for state signals. We're going to be removing side street green pedestrian accommodations. We'll be providing LPI phasing for PEDs and ADA accommodations to cross Route 15. We're updating the detection. We'll be including CCTV that'll be wired into the operations center for operators and engineers to remotely observe operations along the corridor. We'll be implementing automatic traffic signal performance measures, which is part of FHWA's Everyday Counts. It's EDC 4. We'll be including adaptive traffic signal control, which is part of FHWA Everyday Counts EDC 1. And we'll also be including connected vehicle technology, which is part of the National Operations Center of Excellence Signal Phasing and Timing SPAT Challenge. This will be the first DOT corridor, Connecticut DOT corridor, to implement vehicle to infrastructure communications. And there are huge future safety benefits with this vehicle to infrastructure communications, with some potential applications being able to warn drivers when their speed and the signal timing indicates that they may run a red light. There's similar applications that could warn a driver if they're approaching a railroad crossing, and that's tied to the railroad gate activations. There's notifications associated with pedestrian push buttons and emergency preemption. And to get a little more detailed into these components, I'm going to turn this presentation over to Jay Lockaby. Jay?
All right. Thanks, Matt. Can you hear me? Yeah, I think so. Sounds like it. Anyway, if you go back one slide. Yeah. So before we really started getting into the full design of this project, we went through the systems engineering process. I'm sure some of you familiar with, as this is the ITS CT joint as well, know this diagram, or the V diagram for ITS and any complex engineering process. It begins on the left-hand side, but everything on the left-hand side also has a corresponding integration and composition on the right-hand side that it kind of combines with when you're finishing up the design and integration and validation. In the beginning of the systems engineering process, we looked at the existing ITS architecture in Connecticut. As you'll see later, we made some changes to the regional architecture. You go through concept of operations, design, you evaluate what type of technology and what best fits your specific project needs. And then as you go down through the V diagram, you actually get to install it in the field, go through testing, verify the subsystems before you can actually validate the whole system and determine responsibilities for operation and maintenance. Slide. So yeah, the first step of the V diagram is to look at the existing ITS architecture. The state of Connecticut developed our statewide ITS architecture in 2018. And that was based on ARC ITE 8.1, which is basically federal ITS architecture guides to build your own specific, regional ITS architecture. But a couple of things were left out that are specific to this project. And when we went through the systems engineering process, we had to develop this type of diagrams so that when we implement it, we have a plan of action. Some of these include our connected vehicle technology, so the onboard equipment for our maintenance fleet, as well as the roadside units that would actually be projecting out the connected vehicle technology messages. And then also we developed a diagram to plan out our ATS PM server and management of the web page as well as the integration to our central software. And yeah, so those were developed to show how everything is connected with our connected vehicle technology and testing it out with our fleet vehicles. Slide. Through the V diagram process and systems engineering, we went through, we evaluated a variety of different types of technology. We looked at all the different types of signal controller types that would be correct and best fitted our needs for our project. We looked at several different adaptive signal control systems. We looked at several different types of software that we could potentially use for our ATS-PM, and as well as our connected vehicle technology. And then, as some of you probably know too, with the SPAT, and originally the SPAT challenge was to try to get more local and state agencies to build this type of signal phasing and timing messaging out in more projects to make it more available. And the FCC has gone back and forth on their feelings about DSRC as well as CV2X. So that was a lot of discussion when we were going through the systems engineering and the SEMP that we ended up developing. And we also, looked at snowplow priority and CCTVs, but that wasn't as much of a discussion as some of the other type of technologies. Slide, yeah. So obviously we involved all types of stakeholders, including our own ITE, all the local towns. We had a lot of help from our consultant engineers to reach across, the country, try to get different types of advice from other agencies that have deployed this type of technology. And we used all of this information, all the left side of the V diagram to come up with our final plans, which we are finishing up currently. So some of the basic stuff that we do with any traffic signal replacement now: updating our pedestrian features, providing signal heads for all pedestrians, getting rid of our outdated side street green pedestrian phasing that's not very intuitive for pedestrians. We are making a couple of median openings on the Berlin Turnpike for pedestrian crossings. I think almost all intersections will have crossings to cross the Berlin Turnpike. And in order to help with the new pedestrian activity that we're hoping we kind of induce with providing these type of features, we're looking at putting LPIs for all of our pedestrian crossings, letting the pedestrian get out to the street so that vehicles can see them before the vehicles get the green light. And obviously ADA compliant sidewalk ramps. But due to the limited scope of just traffic signals, we weren't able to include a lot of sidewalk infrastructure along the turnpike. So just basic layout of some of our crosswalk locations. This is a before, obviously no crosswalks, limited pedestrian push buttons, and if there are out there, it's just for side street green pedestrian phasing. And then this is the after with our crossing across the turnpike as well as through the side streets. As Matt discussed earlier, we are not only trying to get rid of old loop technology on the turnpike, but across all of our signals across the state. So in this project specifically, we're using grid smart cameras for the stop bar detection, and we are using Wavetronics radar detection for advanced detection. Again, these technologies were part of our systems engineering process. The Wavetronics radar technology we found was appropriate for this project. And as we know, we don't have to go out there and close a lane of traffic for loops. We can just go out there and put a new camera out there if something fails. Slide. So adaptive traffic control technologies. The one of the larger parts of technology that we're going to be piloting on this project. The idea is that the adaptive control will automatically learn and adapt using advanced computer algorithms to adjust the green times and offsets and cycle lengths in real time without us needing to change it manually. And the Berlin Turnpike was a good route for this because there are a lot of incidents, throughout the Hartford area, and people are diverted to the Berlin Turnpike quite a bit. So the adaptive control will automatically adjust to this much faster than we would be able to manually change all the green times and offsets. It seems like this would be kind of an automatic thing where you just turn on the switch and it figures out all the times and everything's great. However, there's still a lot of implementation and engineering that needs to occur once you put it out in the field. Again, to go back to our V diagram, there's an extensive right side where you verify at a subsystem level, then the whole system, and then finally, still maintain it at the end. So there's still a lot of input that you need once you install it. But the idea is to reduce travel times and reduce emissions. So with the adaptive control, we are putting out ATC controllers, and we've also decided on Synchro Green as our software for the adaptive traffic control technologies. When we were looking at different types of vendors and software, we were pleased because Synchro Green was compatible with our existing system. We already use some of the, not necessarily Synchro Green, but the same manufacturer to manage our IMS systems and our CCTV cameras. So that was obviously a plus. And also it will be integrated with our existing preferred, at this time, traffic simulation software. So Synchro will allow you to simulate what Synchro Green software would actually do out in the field, which was a plus since we're already using that. Slide. Connected vehicle technology. As I said before, this was pushed by the federal government as part of the SPAT challenge, or the signal phasing and timing, and AASHTO. So the idea was trying to encourage all types of agencies to get this type of technology out there, encourage car manufacturers to also use software, see that it's being used, see that it's being installed. And the idea is that the technology will broadcast messages based on the signal phasing and timing to the cars that go by. It can broadcast information such as pedestrian phase activation. So if somebody's pushed the push button, it can send out a message to the cars that the push button's been activated. It can alert to vehicles that the preemption's been triggered and that there might be an emergency vehicle in the area. And then also we are looking at it for signal priority and snowplow priority on our maintenance fleet vehicles. And like I also said before, the FCC has, which is a separate entity from our own transportation industry, is trying to make available some of the frequency ranges that are available to DSRC and make them kind of shrink them for DSRC purposes for our own connected vehicle technology and make it more available to other uses. So it has been kind of a back and forth on whether to use DSRC or CV2X. So as part of when we were evaluating that technology, we're going with dual use roadside units so we can use either type of communication. And we are hoping to be, well, we will be adding to that number of nationally deployed SPAT challenge traffic signals. ATSPMs. So what ATSPMs are, just briefly, is the collection of high resolution data from all the detectors at a traffic signal. The idea is to take all of these enumerations of when a detector was activated, compile it, bring it back to our central system, and then deploy software that'll actually take into account all these detection activations, and we will be able to run our own reports on how all the signals are operating. We'll have this for the Berlin Turnpike project, but we're also hoping to expand this to other signals. So you can get information based on, like I said, the detection actuations. And then from that, you can pull up how well the coordination is happening across signals. You can see if a lot of people are running red lights. You can see how often the pedestrian push button has been pushed. There are a lot of great benefits that can come from this, including proactive maintenance. So if you see a push button being activated 300 times from 3 a.m. to 5 a.m. in the morning, obviously the push button is broken, and you can go out, fix it, and nobody will even know the difference. And this website will be available to the public once it is. Thank you. Yes. So this is an example of the website for ATSPM. So this will be available internally DOT, but also for all the signals that we've connected to. Several other states have already kind of run this public facing website. I know, so this is Georgia DOT's website. Utah DOT has a website. There are several other agencies that have these type of ATSPM software websites, and this is free software, which is always a plus for public agencies. And from this, anybody can get the same type of traffic signal performance measures. Slide. These would be advanced technologies on other projects, but we've had success in implementing these technologies, and so this will also be added onto this project. So we'll have our CCTV cameras. Obviously, we'll have immediate video feed and be able to verify any signal operations that we need to. And then we're also connecting all of our signals via fiber optic lines and replacing our existing out-of-date copper communication wires. Obviously, that fiber optic has increased reliability, and it is compatible with our current signal technologies. Slide. So this project initiated 2 years ago. We are finishing up design currently right now, looking to get it out to a contractor this summer. And we have been trying to expedite everything with this project. So we're hoping to finish up the physical construction next year, 2022. Obviously, there's still a lot of verification and implementation and engineering to do once it's in construction to make sure all these technologies are working correctly. And our current construction cost is $10 million, 80% federal, 20% state. And I think I'm going to send it back over to Matt.
Thanks, Jay.
Yeah, cover some of the go ahead.
Thanks, Jay.
We're a great team. You'd think we'd be a little bit better after a year.
So like Jay said, all this technology is planned to be installed within the next year for testing as part of the pilot project. That's really the end of the presentation portion that we had planned for this evening on Project 7250. But before we open this up for questions, I just wanted to take an opportunity to talk about some DOT related reminders and items. So something I just wanted to mention as a reminder is we now have an email mailbox, dot.trafficengineering@ct.gov. We really encourage everybody to use that when they have any new inquiries or questions, requests for signal plans, coordination timing, or any other information. It's helpful for the consulting industry in that they don't have to worry about which engineer to send it to or what district it's in. It from your perspective, it doesn't matter. Just send it into the mailbox, and from that mailbox, it'll get sorted to the appropriate person, and we'll be able to get a response out to you. The other thing I wanted to mention was the Local Transportation Capital Improvement Program. That was established a couple of years ago, and it's got substantially fewer constraints than are required when using Title 23 funds for projects, which really comes down to the fact that the DOT kind of stays out of the review process for most of those projects. The one thing I wanted to mention is that if your project has impacts to a state road, or it involves a traffic signal in some manner, please coordinate with the district permit office early in the design process, preferably at the PD phase, just so we can figure out an appropriate level of DOT review. The last thing that we want to have happen is a set of plans get developed to the PS&E phase, and when it comes in for an encroachment permit, find out that the traffic engineering division needs to take a look at a signal or something. The other couple of things I wanted to talk about is the DOT's website. This website's updated constantly. There's a link on your screen. It's a very convoluted website. The easiest way to get to it is just Google CT DOT traffic engineering. It'll bring you to our website. It's broken down in a couple different sections. The first one really talks about what each section of the Division of Traffic Engineering does, specifically the first three. The fourth one is the safety engineering link, which not only talks about the responsibilities of that unit, but also has an awful lot of resources. It's a good place to go for safety related information. There's tables about pedestrian countermeasures, RRFB guidance, sample plans if a consultant's looking to put together an RRFB and wants a smooth process through the review. There are sample plans there for that. We've got crash mitigation factors and a bunch of other links in there. We also keep updated our traffic documents. The first two areas are our special provisions and our standard drawings and design guidelines. The next one is our traffic signal design manual section. And if you click on that, it brings you to a bunch of other resources in addition to the design manual. So there's a document about interim pedestrian considerations, pedestrian signal design technical information, and some general signal design preferences. A lot of this will eventually be brought into a newer version of the design manual, but you can find a lot of interim information there before a new design manual gets published. And then finally, on our website, we have links for our sign catalog and traffic detour evaluation information. It includes some guidance for detours, sample plans. And there's also some information about signals with railroad preemption and some other items as well. So with that, I think we're going to open this up to questions. I think the way that we're going to be handling this is to take your question and populate it into the chat, and then we'll be able to respond. If you have any questions after this meeting, you come up with anything else about 7250 that you want to know. Perhaps you have a question that we just can't answer for you tonight. Please feel free to email me, matthew.bloom@ct.gov, and we will get you an answer as quickly as we can. But for now, if you've got questions, just populate them in the chat.
Great. We got a couple questions already. Feel free to keep sending them into the chat and we'll get to them. First question is about plow preemption. The question is, how does the signal know the plow destination and route? Can municipalities upload routes tied to the vehicles? What needs to be added to local municipal vehicles? And is that in the contract to provide those devices in the vehicles?
So the signal does not know the plow destination route. It's going to operate sort of like preemption, except it won't be preemption. It'll be a priority. So it'll have less of a priority than preemption. And so it'll essentially operate like preemption, but it's not preemption. And so, yeah, the routes really aren't factored into it. And at this point, we are kind of using the plow priority more of a testing, piloting of the CV technology. We don't, because there's no really way for us to test that technology unless we bought some and try to use it on our own. On our own technology, on our own state vehicles. So it's to be seen the benefit of the snowplow priority, but we're hopeful.
Great.
Matt, do you have anything to add to that?
I think that covered it fairly well. Again, it's a pilot project. We're trying to see how this works, and really the only way to test it is to implement it in a couple of our vehicles, which we're going to implement in a couple snowplows.
Great, thank you. And beyond the second phase of the Berlin Turnpike, are there other corridors the DOT would be looking to implement similar technology?
So there are other corridors that could potentially benefit from this type of technology. But right now we are just in a pilot study process. So all of this technology isn't easy to implement, and it does require it to be managed. So it's a process to add corridors, and we want to make sure that we understand the requirements and the level of involvement from personnel to get a system up and running. And the answer to that question will really come once we get this pilot up and running and see how it works.
Great. Regarding V2X safety, do the grid smart cameras or radar trigger the RSU? Can you elaborate V2X safety use cases and sensors being used?
So I believe the RSUs will be sending out the SPAT messages automatically. The grid smart is completely separate from the roadside V2X unit. I don't know. So they are just messages at this point. So I mean, I don't know if there's any safety issues known with the V2X roadside unit. At this time, it's more informational messages until it really gets deployed on more cars, automobiles.
Great.
And it's very early in the deployment of VTI, so vehicle to infrastructure and vehicle to vehicle technology. So we're really early for use cases.
What is the minimum depth of the fiber conduit that you're running? And will it be concrete encased, and will it be 3-inch rigid metal conduit?
So I can cover this one. So it is RMC, and it's existing. So right now there's a copper communication corridor along Route 15 that's used for the existing traffic signals. There's both a used conduit and a spare. What the project plans to do is run the new fiber in the existing spare.
Great. Was there an evaluation of the anticipated operational improvements with the ATC system versus a standard coordinated signal system in terms of travel time, stops, etc.?
Yeah, so I think the first part of this, so the adaptive is for use when it's unpredictable. So it's hard to evaluate how much improvement you're going to have when it's used in these out of the ordinary situations. Um, and, as far as normal time, our normal time evaluation, our timing plans, we're going to optimize those as well. But the adaptive is really for these out of the ordinary type situations that are kind of hard to simulate.
Great, thank you. We have a question about crossing times in LPI. The question is saying the crossing time will be high for crossing the artery. With concurrent PED timing, will you need to stop PEDs in the median? Side street green will need to be increased to cover the PED min times and could increase delays. And yes, were PED counts done?
Yeah, the crossing time will be high, and there were a couple of locations where we thought about stopping the pedestrians in the median. One, we are still planning to do it at Kitts Lane currently. That is the one location where we are looking at stopping the PEDs in the median. That's currently how we have it designed. It's tough though, because usually when you look at the turnpike, you see people crossing all over the place. It's not in an intersection, and it's sometimes easier, if you're darting across the Berlin Turnpike, to do it in between an intersection. So I mean, we have PED counts, but it's hard to verify if that's actually the pedestrian demand out there.
Sure.
To be clear, we don't recommend anybody dart across.
Sorry, yes.
15.
That sounds good. We had a question about the funding source and which program it was funded through.
This is programmed through the HSIP program. It's not CMAQ.
Thank you. And we have one more question right now. Are you expecting to maintain all this new equipment as the department, or is it likely that a service maintenance contractor would be used? And was ongoing maintenance part of the scope?
Right now, we have a 1-year contract for maintenance of the technology, for implementation of the technology. Also, all of the detection we have out there, in order to get it to make sense in the ATSPM software, it takes a lot of configuration. So there's considerable amount of engineering configuration that's going on. So we do plan on having a consultant on board for a year to help with this configuration and implementation. But after that, we definitely are anticipating to maintain this equipment ourselves.
Great. There is talk about a regional ATC amongst DOTs in New England. Is the department considering participation in that program?
That I don't know the answer to. I'm going to have to get back to, who is this, Joe?
Joe Balskus, yep.
Yeah, Joe, I'm going to have to get back to you on this. I can talk to planning.
And that's all the questions we have right now.
Carl, maybe I could jump on and ask my question instead of typing it, since I'm a co-host. I don't know if I get special privileges or not.
Please.
I don't know. Matt, did you mention if you're doing any public outreach around this?
We had a public information meeting. And
yeah, go ahead.
Which components are you thinking about?
Well, actually, kind of what I was thinking about. I've heard about this project for a while, and I've always thought that it was pretty admirable of you guys to let the guinea pig be right out on your front doorstep. Actually, the thing that I'm wondering about is what kind of feedback you've gotten from within the DOT on this. Has there been any concern, or is everybody pretty much like happy, ready for it to go?
I think everybody's happy and ready for this to go in. It's new technology that's time has come to be installed. And
yeah, man, I was just going to add to it. I think this has the full support of Mark Rolfe, Deputy Commissioner. He's the one who's who's been promoting and excited about this project and really pushing the design team to accelerate it as much as we can optimally do it. So you're right, Matt, this technology, the time has come. We're deploying portions of it outside of this corridor, things like the 360 cameras and some of the other things that were identified. But I have to say the department's very excited about getting this project out the door.
That's awesome. Thanks.
We have another question about transit integration. Are bus stops being integrated into the design?
So the design did take into consideration bus stops. When we started reviewing the corridor, we did notice that a couple existing bus stops weren't in the best locations. So the project is going to actually move them to much more appropriate locations. So as part of the process, we did look at the existing transit facilities.
Great.
Matt, this might be a good point to kind of jump in about the pedestrian crossings too. You know, the department's taking a very strong and active look at providing pedestrian crossings at our signalized intersections where we can. As Matt and Jay mentioned, we're getting away from the decades-old side street green that we've had out there and going where most of the country has already gone with concurrent pedestrian crossings. Active bus stops are just, you know, one of many reasons that we want to provide appropriate crossings across a facility like the Berlin Turnpike. And yes, there may be some delay to traffic at various times, but it is one of the things the department is committed to is to provide safe crossings for pedestrians, or this appropriate crossings that provide additional safety for pedestrians. So you're going to see more and more of that type of message coming out through a lot of things that the department is doing.
We have a question very related to that. And what level of public outreach is being done for, I guess, teaching the public about how LPI works and the new LPI implementation?
So there are a couple of other projects beyond this one in this area that are implementing LPI, and they are doing an educational process as part of that. And we will probably very most likely piggyback onto that process as we advance into construction.
Sorry to keep jumping in and adding, but you're right, Matt. On that website that Matt pointed out, there's some resources on there very specifically designed for education related to concurrent pedestrian designs. There's a PowerPoint that can be used by municipalities and consultants whenever you're engaging constituents. That's a resource that we have posted there. We've also partnered with Watch for Me CT, which is an effort out of the departments in the planning department, the highway safety office, working with Connecticut Children's Medical Center to produce a fact sheet and brochure informing both drivers and pedestrians about how to use a concurrent pedestrian signal. So it's going to take some time re-educating all of our residents in Connecticut through anytime we've all grown up, we've had certain type of signals out there. But the more and more we can get this out there and promoted, I think the better we're going to be.
I just posted that PowerPoint on the in the chat if anyone's interested. No more questions, it looks like. Give it a minute in case anyone's typing.
Well, if that's the case, I really want to extend my thanks and appreciation to Matt and Jay for this presentation here. As you can tell in their voice, everybody's very excited about this project and the technology it's going to bring not only to the Berlin Turnpike, but eventually across the rest of the state and our other signalized intersections, our corridors through the state that handle the boatload of our economic activity and pedestrian activity. So with that, thank you both. Appreciate it. And I want to thank everyone for tuning in and participating in this this brief hour. But we're looking forward to hopefully doing these things a year from now in person and seeing everybody face to face. So with that, I'll turn it over to Carl if there's any last things.
Nope, just some thank yous in the chat, and thank you very much, Jay and Matt, for presenting. That was great.
And I know
Thank you for having us.
CJ had to leave early because of another commitment he had, but again, thank you everyone, and we'll see you soon.
CJ's here. In case
Yes,
anyone's-
is he still? Oh,
I'm
good.
hanging on still. And
Oh,
thank you
good.
again,
All right.
guys.
Take it away,
Great
CJ.
presentation. Very nicely done. And let's hope for next year we're in person.
Absolutely.
Got it.
Thank you.